As we start now, section 3 of chapter 12, we're going to do this in two parts. The first part will be the quadratic formula, these two, and then we will have a separate part, part 2, for the discriminant, and we'll use that and define that when we get to it. Now, as we look at the quadratic equation, and we'll see that on the next slide, the letter A, and let's go to the next slide, this letter A here, if it is ever negative, they are suggesting that if this were, let's say, a negative 2x squared plus 3x minus 5 equals 0, that you multiply the whole equation by a negative 1 to make your leading coefficient, this letter A, positive. It works so much better in the formula. It doesn't change the answers, but it allows you to work this formula a little bit better. Now, what they've done here is they've taken this formula, and by using the method completing the square, they've actually solved this equation for the letter x. Now, when it's in this standard form, everything is over on the left. You can identify your A value, your B value, and your C value, and you then put those values into this formula. Now, it must be in this form because it was this form that was used to make the equation. And you need to be careful, of course, of the signs as well. Now, there's some negatives in the formula, and you respect that as you put that in, and we'll see that worked out as we go on. Okay. So for example 1, letter A, write this in your notebook, of course, and we're going to do some substitution. Now, the first thing we have to do is to identify what the A value is, what the B value is, and what the C value is. It is in standard form. So our A value is, of course, this 1 that's not written. So that's a 1. Our B value, including the sign, is a negative 5. And our C value is 3. Now the formula is x equals negative b plus or minus the square root of b squared minus 4ac. All of this is over 2a. Now, I meant to mention that up here, toward the top of the screen, there should be like a little letter I here. If you click on this I, you'll get a drop-down menu in which I made a video in which I have the quadratic equation, and then I solve it using completing the square to derive the quadratic formula. So, that'd be a little supplement there. So we start filling it in. X is there. Now a negative b. Well, b itself is negative 5. So if we take the opposite of a negative b, that gives us a positive 5. Plus or minus the square root. Now we're going to square a negative 5. Negative 5 times negative 5 is 25. Minus 4. A, we said, was 1. And this is how you should do it. And then we said C is 3. And all of this is going to be over 2 times 1, or 2. 2a, a is 1, 2. So then we start to substitute. 5 plus or minus. Now this is going to be negative 12. If I take 12 from 25, I get plus or minus the square root of 13. And this is all over 2. And you've gone about as far as you can go. And let's check this out. So they're identifying the A value, the B value, the C value. This is the quadratic formula. They've substituted. Keep in mind the opposite of a negative 5 makes this a positive 5. You're going to subtract the 12 from the 25, and there is your answer. So this one was pretty easy and straightforward, with a number of background items. Again, putting it in standard form, identifying your A, B, and C terms, and then carefully substituting. Okay, let's do this one. So our A value is 7. Our B value is negative 2. And our C value is a positive 1. Now you want to substitute these values into the quadratic formula. Now notice our B itself is a negative 2. So whenever that's true, when B is negative, this first term here is going to end up as a positive, because the negative signs in the formula, the negative of a negative, makes this positive. And we'll give you some time to copy this down. I could write it all out, but it's so neatly done here, and you want to be sure you understand what's going on. Now notice here we have a negative 4. I would have put these in parentheses, but that's all right. So this value here is going to end up being negative. So you now have a negative 28 and a positive 4. This is going to give you a negative 24 under the radical sign. So this is not going to be a real number. This is going to be our imaginary numbers that we spoke about earlier. And when you finally get to this point, you get this. Now, let me go over how they got this. This is a review of an earlier chapter. We had under the radical sign a negative 24. Well, we're going to take out the I. That makes this 24. You recall the I was the square root of negative 1. And then we said in an earlier section, the 24 can be divided into 4 times 6. And the 4, square root of 4 is 2. So there's where we get the 2i, the square root of 6. Now, notice here you have a common 2. So you can factor a 2 out of this, and it will look like 2, this will be a 1, plus or minus I, the square root of 6, all over 14, that I'm going to go 2 times 7 here, just to show you what's happening. So now we have a common factor of 2, so we can cancel that out. So then our final answer is 1 plus or minus I, the square root of 6, all over 2. Okay. So you see where it's coming from here. They're factoring out the 2, and they did actually what I did. All right, very good. And notice, in a sense, these are conjugates, aren't they? And we call them complex conjugates because of the letter I. They're not real numbers. They're complex numbers. Part of it is imaginary. Okay, take a moment, write this down. And you might say, wow, wouldn't it be difficult putting in all those fractions into the formula? And absolutely. So what we're going to do is, I would think, put it in standard form, and then we're going to get rid of these fractions by making it an equivalent equation but without fractions. Your x values are still the same. So you're going to multiply each term by the lowest common denominator. We did this many times in the past. And I would have brought that over to put it in standard form first. Okay, you cancel out. You end up with this. You're going to transpose this 4 to the other side. So it becomes a negative 4. Remember, we have to identify our A, B, and C from being in standard form. So this is not your C value. When it comes over to this side, it becomes a negative 4. That's your C value. Okay, they're showing that here. And now, once you've identified your A, B, and C, you put it into the quadratic formula. And there they're showing them up here. Your C is a negative 4. That's correct. So you get your values, do your multiplication, expand this. By the way, this will always be positive because you're squaring it. And then when there's a negative in the formula and then at least one negative, this will become positive, as you see here. Now, again, you had to tease apart the 180, and that's going to be 36 times 5. The square root of 36 gives you the 6, the square root of 5. And then what do you think can be done here? Well, you can factor out a 6 from each of these terms, and this is 6 times 3. So you will cancel these out, and then your final answer will be this. Now, if you were to put something like this into MATLAB, they would count it wrong. And if you did that on a test, again, having all of this part correct and doing all the work you did, you would get partial credit, lots of partial credit. Just not simplifying this last step doesn't make it wrong. Okay, they're showing us some common errors here. And let's take a look at it. So here we have a 4 plus 2, the square root of 3, all over 2. And what they're indicating is they're going to cancel out this 2 here. Well, you can't cancel out this 2 because this 2 here is not a factor. You can only cancel out common factors. So over here, let me write that in there so you can see it a little bit better. You would have to factor out of here a 2. 2, so 2 goes into there twice, plus 1, the square root of 3, all over 2. So now you can cancel out this 2, because this is a factor. Here, this is just part of a term. Okay? And then here they're showing you the correct solution, which is what I've done up there. Okay. Common error. Now, in example 2, they're saying that what they want you to do, this is a cubic equation. This is to the 3rd degree. So what's your strategy here? Well, notice you could factor out a 2x from each of these terms. So this gives you then x squared here minus 5x plus 3 equals 0. Now, a technique we had in the previous section was to say we could equate this to 0 and then theoretically factor this. But this is not factorable. But we already have one of the solutions. One of the solutions is 0. So we can take this part and put it in the quadratic formula. So let's do that. X equals, now our A value is 1, our B value is -5, and our C value is a positive 3. So our B is -5, so the opposite of a -5 is a positive 5, plus or minus the square root. -5 squared is 25, minus 4 is in the formula. Our A is 1, our C is 3, and this is all over 2a, which is 2 times 1 is 2. Okay, we do a little substitution, and we have now our calculation. So, -4 times 3 is -12. From 25, we had one like this already. This was the square root of 13. So, this is as far as you can go here. There's no common factors. Now notice you have 2 answers here, as it's plus or minus, but you also have a 0 from this one up here. So we have used factoring for part of the solution and the quadratic formula for the other part. Alright, let's go on. See what they show us here. So there's one solution, and there's the other, and I worked that out for you. Okay, and by the way, this was the example we did in 1a. Alright, they kept it easy for us. So you have 3 solutions in a cubic equation, that is to the 3rd degree. Okay, this will wrap up this part, and we'll pick up on the discriminant here in just a few moments.